Ladies and gentlemen, it was correctly pointed out we did not finish our last activity. We're supposed to do a mechanism for all the products. We did not account for this product. This is good. This came up this way. It's a separate video. It's the rearrangement one. How do you know a rearrangement is necessary to make this product? What is the obvious giveaway? The OH is not on either carbon of the original alkene, is it? No. Something had to move first. Ladies and gentlemen, the only cations that are candidates for rearrangement are a cation adjacent to a branched carbon. This carbon over here is not a cation adjacent to a branched carbon. There's no branch there. This carbocation is next to a carbon that has more than one carbon attached. That's a branched carbon. This is the one you need to do a second copy of the cation, where the majority of these cations are not doing what I showed here. They're doing this instead because it leads to a more stable carbocation. So if you're not used to my new symbol here, that's an equivalency symbol. It's not a triple bond. It's a mass thing. This is exactly equal to this is what that means. And in this one, I hope you see it's this H that has to move, because that's where the OH needs to go. And right now there's 4 bonds there. It's on the branched carbon, isn't it? Use that new thing I gave you to help you remember, when do we get a rearrangement? You've got to be branched, one away from the C+. Move the H. There's another point. We're up to 10. 11 for the intermediate. Here's oh, it's green. Cation there. How do you get the O onto that cation? Same way we got the O onto the other two. Water. I need a third molecule of water drawn. Yep. And that's another point for this intermediate. Oh, 1 point for this intermediate, that's 11. 1 point for this intermediate, that's 12. You lost a half point for the formal charge, but you got it back because you put it on just in time. There you go. Oxonium. And then we're going to go to major. And if you do it that way, you better tell me this one's major. And how do I get rid of the H? Same way I got rid of the H the other 2 times. I'm going to need to draw another molecule of sulfate, bisulfate, hydrogen sulfate, however you want to say it. And that gets you to the major. So that's another point for the mechanism there. We get it up to 13. Yeah, 10 for the rearrangement, 11 for the cation, 12 for the new intermediates. Oh, 1 point for the rearrangement arrow. 1 point for the mechanism part over here. Yeah, that's an arrow. It's huge. 14 points. 1, 2, 3, 4, 5, 10, 11, 12, 13, 14. Wow. And mechanisms get more and more important. And the final exam is half mechanism. You can't say, oh, I don't think I'm ever going to get it. I give up. No. You can say, oh, I don't think I'm ever going to get it, but I'm going to stick to it. And I'm going to die trying, kind of thing. Stick to it. So, harsh words. I didn't mean to say those, but you know what I mean. You got to really buy in, because it's how things happen, everybody. It's how the things work. It's profound. All right.